Connected on VC link? Anyone connected on VC link?
No, sir, only fancy works. No, check. Hello.
This RGMTTC this place frequently given for shooting.
The meaning for the shootings.
Next, how many? Yeah, I know the best one. You might have That's one more
Of course, I could be.
I have like but it's pieces or something.
I think company is using using digital started continue working in
They don't need that much of. Yeah, I am.
Yes, sir, we see any
Only YouTube.
yeah, YouTube. Any number of people can watch because we want to share to our people. That was the complete share. As of now, as of end of the day, at least. Actually, some states have not like it. So they share. So
I cannot do it. They have to do
that's slideshow. Nothing is visible.
sir, they are being available here only, sir. Actually, on sir is asking. This image also is not clear. You can see this image is okay. But the image they are taken, so screenshot is not clear.
Okay. Share all.
Okay, sir, you get the consent, sir. To switch on this one. It's remote. This one. This is.
इसी में पर्टिकुलर नहीं करेंगे कोई नाम पढ़ना
Use the mic, sir.
Hello.
Sir.
Hello, everybody. Welcome again after lunch. So I think I know it is very difficult to attend session after lunch. So I'll try to make it more interactive. Right. So shall we start? This is our 4G architecture solution. And Mr. Maral already told about this. I would like to add some points actually. Here, if you see, in mini DC there are two components. One is MGCF. So what is MGCF? Do you have anybody have an idea what is MGCF function of MGCF? It is called media gateway control function.
So it's between IMS and non-IMS.
Yeah, MGCF is basically to interface with the your legacy switch actually. TDM, the the existing switches actually, TDM switches. So basically, media gateway configuration basically connect to the S gateway and P gateway, not S gateway, that is called signaling gateway, and media gateway, and they are connected to the existing switches. And that is IBCF. What is the function of IBCF? It is basically to connect another IMS network. Right. So MDCF is basically from IMS to non-IMS, and IBCF is basically IMS to IMS. And yes, right, yes. And in the below, there are certain all DPs actually. So this is our CAPS architecture. Now, what is the advantage of CAPS architecture? Mr. Model already told that our control plane and user plane are separate. There are separate instances of node actually. So what is the advantage of this CAPS architecture? Just can anybody tell? Now, what is CAPS architecture? You already know. You can put our control section in a geographical area, and DPs you can put some other geographical area. Nearer to the eNodeB side, to the user side. So what is the advantage then? The latency will be less, right? Because the voice packet will be going from your eNodeB to DP, then trigger to DP, and then the internet, right? So the latency will be there. So that is the advantage of CAPS. It is called edge computing. So some of the nodes are on the edge of the cloud actually. Right. So these are some of the features of our CLOT NT core. Our solution is based on 3GPP, and our core of supported is non-3GPP access network. Non-3GPP access network is Wi-Fi, and now this CPDG. And now is scalable architecture. That means depending upon load, to go on increasing the resources, go on increasing the VMs, and your load capacity will be increased. High availability, support of all EPC nodes. All nodes are working in active and standby node. So if for some reason one active node goes down, the standby will take care. Right. Our code supports seamless and one across 4G and 2G. Support of voice and video service using IMS. Support of CBC for urgent messaging broadcasting. So what is CBC? It's called serial broadcasting. So do you know what is CBC? I think most of you know what is CBC, no? And our code supports circuit switch fallback and SRBCC. So circuit switch fallback and what is SRBCC?
Single radio voice call continuity.
And what is the difference between circuit switch fallback and SRBCC?
Setup itself will be done by CS. SRVC call will continue from IMS to non-IMS.
Yes, exactly. So, circuit switch fallback means you are in 4G network, but for some reason, suppose your handset is not supporting IMS or there is no IMS network. So, in that case, the call, which you initiate a call, MME will forward the call to the MEC, and then handover takes place from 4G to 3G. So during the call, the subscriber will be handed over to the 3G, and at the end of the call, again it will move to the 4G. So that is what circuit switch fallback. So what is the main circuit switch fallback? That means that particular area should be supported by 4G and NLP as well as rare nodes. Right. And what is SRVCC? SRVCC means you are making a VoLTE call and you are the conversation is ongoing and you are moving from 4G to 3G network. Right. So circuit switch fallback means you are initiating a call, and SRVCC means you are already in the call and you are moving from 4G to 3G. So that is the difference between circuit switch fallback and SRVCC. So both these features are very important features of LTE call, and we support both. So is it clear what is circuit switch fallback and SRVCC? Right. Next one. Now I will explain some of the basic terminology of LTE. Next. So what is K11 ID? We already told multiple times that K11 ID. What is K11 ID? Many of you know, but K11 ID is basically consists of MCC and MCC. Now what is MCC? Mobile country code. For India, there are two codes developed. One is 404 and one is 405. So these are the two ports. This is switchboard area. And MNC means mobile network port. That means like for Airtel, they are having some MNC. Like for BSNL, they are having some MNC. Like for Chandigarh, the MNC is I think 053. Like that. Okay.
Both combined.
Both combined. Okay. Okay. So MCC is 3 digit, MNC will be 2 digit, or maybe 3 digit also. Right. So this is what is available ID. MC means International Mobile Subscriber Identity. So MC consists of MCC, MNC plus MSIN, Mobile Subscriber Identity Number. So whole MC basically consists of 15 digits. So if MNC is 2 digit, then MSIN will be 10 digit, and if MNC is 3 digit, then MSIN will be 9 digit. So whole MC is basically 15 digits. So MC basically uniquely define a particular SIM, particular subscriber. That is unique to a particular SIM. See, we have the terminology of enemy entity. MMEC means enemy code. MMEGI means enemy group identity. I will explain. See, there is a concept of pool in LTE, depending upon the load. So whenever there is increase of load, you can have more number of enemy instances in a particular pool. So MMEGI is basically a pool. Let me explain. So this is the concept of aggregate pool. So they are the individual enemy instance, and this is a pool. So consists of multiple enemies. Remember that in one enemy pool there will be 16 enemies. So you can add maximum 16 enemies in an enemy pool. Right. So what is the terminology? So this is the pool, and I am given the pool number is 1. So whenever you design any network pattern, you have to make it. This is called MME GI group identity 1. So pool is nothing but the MME GI. So we have to configure in our code that for MME GI 1, there are enemies, and this enemy code means code 1. So this is 1 enemy, this is 2 enemy, this is 3. So this means enemy C equal to 1, and enemy C equal to 2. So there are 6 enemies in a pool, and this pool identity is 1. Right. So if you so that is what MMEC. So MMEC is clear, MMEGI is clear. So MMEC plus MMEG is called MMEI. This is called MME identity. Right. That means if you want to find the enemy in a pool, multiple, there will be multiple pool. This is the pool 1, there will be multiple pool. So if there is a second pool, it will be enemy GY2. Right. So if you want to find a particular enemy in a pool, enemy I will come into picture. The enemy I means the pool number, that is enemy GI plus enemy C. So if you know enemy I, you can easily find out what is enemy installed in a particular pool. Right? Sorry?
Not over.
Yes, yes. So what is Gumi? Gumi. So that is what is MMEC, MMEGR, MMEI. So if you add PLM and ID in MMEI, it is becomes globally unique MMEI. Means across the globe you can find out a particular ID. So that is what is Gumi is. Right? So I already explained what is GOTI. GOTI means this is globally unique temporary identifier. Is allocated to a UE by the enemy when UE attaches to the network, and it is used instead of MC to identify the UE. When the UE attaches to the network for the first time, MC is used, and therefore GOTI is used to avoid any security issues or error. That I already explained. Any doubt about this GUMI, GOTI, all these things? Because this terminology you have to face every day when you do actual work. Actually. Now, what is tracking area? This is a very important concept in LT actually. I have shown you two tracking area. So when you design your LT network, this concept will be needed actually. Otherwise, it will be a problem for the network operator. How you define the tracking area in the network? So what is tracking area? That is a concept that developed is called tracking area region. It's called tracking. Right. So tracking. So now what is tracking area is? Under tracking area, you can define multiple tags. It is similar to lab into thing. So this is tag 1, say. This is tag 2. This is tag 3. This is tag 4. So these 4. Now what is tracking area? You know? Tracking area means okay, there is a node B and there are certain geographical area. So you can define a particular area tag 1. So this tag you have to configure in node B. So there will be multiple area node B having same tracking area. That is how you define design a network. Right? So what is the advantage of this tag? And there is a concept of tau. Right? Tau, tracking area update. Right? So what is tracking area update? Tracking area update means the UE actually, the UE basically. This is the UE. After this predefined time, it will send the tau update to the enemy. So what is tau? Basically, it tells the enemy that I am in a tracking area 1. Basically, it updates this location to the enemy after the predefined time. Right. So more the tau update, there is more load in the enemy. So we have to basically reduce this tau update. Now, what is the what actually, there is another node B, this is another node B, suppose this is tag C. This is very careful, right? Any doubt is so suppose this EOE moving from tag 1 to tag 2. So as soon as this EOE moving from tag 1 to tag 2, it has to update enemy that I have changed my tracking area code. So a tau will go. Similarly, when this EOE moving from tag 2 to tag 3, again it has to send tau update to enemy. So that is for one subscriber. In field there will be lots of subscribers. So the load in the enemy will be increased for this tau update. So the design of the network should be like that. There will be less tau update, but the functionality should be same. So that's how this TEL concept. Develop this TEL concept. Now what is TEL? So it is clear, na? This one. After lunch, I think it is getting tough now. Now, so what is TEL actually? So we have defined a TEL1, and after TEL1 there is TEL1, TEL2, TEL3, TEL4. So whenever there is whenever image moving from one TEL1 to TEL2, and from TEL2 to TEL3 or TEL3 to TEL4, no need to send tau update to TEL3 because everything knows this is TEL1. So you can define multiple TEL also. So in our case, we can define 100 TELs in our code, and one TEL can have 16 tags, right? So that is the concept of tag and TEL.
Are you arranging to plan in advance?
Yeah, it is, you know, you can modify anytime. It is configurable actually in the code. So depending upon your requirement, you can configure accordingly. So that is not permanent actually. You can change anytime, and that is configurable. Am I answering your question? It is not dynamic actually, but it is configurable actually.
Demarcation जागृत demarcation is BOIs. Yes, sir. Demarcation is BOIs, and again, factor is FTC. So here, how
See, this is how you define actually. This is how you define the network. That is the features we are having actually. Now that is up to the RAN side or the core side. How you basically design the network. So that there will be less tau update to the core end.
100 TELs.
Total in our code total you can create 100 tabs. Yeah, and each tab can have 16 tabs. Right? Yeah. Sorry. Yes. Not see. P11 is circle wise, right? So in each P11 there will be multiple tracks.
No, 100 TELs in how? Within a
100 tracks
PLM.
in a single P11.
Single.
Yes.
Next.
For each sectors will be different. Each sector the TAG will be
The cell ID will be there.
That is the
For each
Like lack only.
yes, that is exactly. It is like lack of
2G, 3G, we are having lack.
right.
Then cell ID we are having for each sector it will be 1, 2, 3, 4.
So we are having need not be ID, not this ID. But you have to tell PC. I believe not be ID. Combination of the same ID.
Right.
So the existing already lack for that planning is features.
It is almost same lack
Same.
to tag, but there is a concept of TEL which comes into picture.
That if civil planning is not possible here.
Civil?
Planning,
No, I'm not getting you. Civil planning.
using black planning is already available.
Yes, yes.
So the civil person can arrange for talent.
Yes, you can map the tag and lack also. Because 3G network is still
How many lakhs you are having? Same way you can have those many tags also.
right.
It is up to you. You can
See-
combine 2 lakh into one tag.
See, lack concept will be there also. Because 3G network is still there, no?
Your advantage is there we can form a tag
Tell.
tagging area and list out.
Right.
So that we can avoid unnecessary tag.
loading of tower.
But reverse is also there now. So unnecessarily we have to send a paging message in all the
Yes,
tags.
that
is also
yes.
there. So there must be some
There are
compromise.
compromise in between. Right, exactly. Next. Now, what is LTD bearer actually? Every service on LTE requires certain QoS. So, what is QoS? Quality of service. It is basically consists of priority, delay, bitrate, etc. So, if you see in case of LTE, there are 9 QCI. Okay, so in case of LT, actually there are 9 QCI, QCI 1 to QCI 9. So, so each QCI, there are QS associated with particular QCI. Whenever there is two things happen actually. Right. That is called bearer. Now there are before bearer also before and dedicated bearer. Right.
That's it.
So if you see in MT there are, as I told you, there are 9 QCI. So this whole QCI it is called GBR. This note it down capital GBR, guaranteed bit rate. Guaranteed bit rate. And this QCI is basically called SIP signal for IMS. And these 4 are basically for data services. These are called non-GBR. Right. So 6, 7, 8, 9. These are for non-GBR, non-guaranteed bit rate. These are basically used for data. And this is for SIP signaling for IMS. This QCI1 that is mapped to the voice call, VoLTE call, right? Voice. And this is mapped to video call. And 3 and 4 is basically for live video gaming. So note it down actually. Whenever a UE attached to the network, 2 things happen. 2 default bearers will be there, one for data, another for IMS. So when you make a call, VoLTE call, then second bearer, that is called dedicated bearer. That is formed. Now, what is the advantage of dedicated bearer? For dedicated bearer, there is a certain QS which is used for the particular service, like VoLTE or video call. So that is why in case of VoLTE call, we call it a HD quality voice. That means the QS is guaranteed. So as soon as your call is terminated, that particular dedicated bearer will be terminated. But these 2 default bearers will always be there till the phone is in attached state. Right now? Next. Now I'll briefly explain what is roaming actually. See, in LTE there are basically broadly there are 2 types of roaming. One is called home router roaming, another is called local breakout. So in India, for data services, we basically use home router roaming. And for voice call, we basically use local breakout. Now this is what is home router roaming. See, this is the UE. Just note down by a mouse actually. This is our home P11. So one subscriber of home P11, it is coming to this P11. So this P11 is different, this P11 is different. So this UE from H P11 moves to the VZ P11. So that means it comes within this range of this inode B, right? So it sends the attached request to the inode B. Inode B sends this attached request to the MME, and MME knows that it is not the home subscriber because the P11 is different. So it will send because depending on the P11, it knows that what is the HSS IP for that particular UE. So it will send the request to the home HSS. because authentication only takes place its home HSS only. So the UE authenticated in the home HSS, and then it tells the MME that okay, the UE is authorized and authenticated, so you can give the service. So MME will tell S gateway because I already told you now this E node B is basically physically connected to the MME and the S gateway. So for this EUE, this MME is visited MME and this S gateway also visited S gateway. But in case of home routed, MME tell S gateway to say to create a session for this particular EUE with this P gateway, right? So S gateway will send a create session request for its home P gateway for that subscriber, and ultimately the service will be given from this home network of this particular service. So that is it is called home routed roaming. And P gateway again sends CCR, it is called credit control request to the PCR, and finds the QoS defined for that particular subscriber. And P gateway again give the same QoS to this particular subscriber. So that is how home routed roaming works. So any doubt?
MME and SWC at same location.
MME is a visitor here.
MME at same, now once pieces deployed, MME and SWC at same location.
Right.
So if it has to move to the Tamil Nadu, so in that case also,
Right.
it will come into play.
Right. It will authenticate to this home subscriber, HSS one.
What you are using, data channel changes, data channel to customer, very deeply into the. So in this case also.
Yes. Because they both are the separate PLM. Yes, you are telling something. Yes, this is only for data. Only for data. So in
actually we are using the systems of Punjab. This will be applicable, right?
Right. Yes.
So in that case, actually, I have some with the Punjab, say, I say we are not getting.
Speeds actually there are multiple factors actually for speed actually. So that I cannot say actually, but because MME will not come into picture for speed actually. This is the signaling part. The speed come into this DPs, this E node B. They are all basically responsible to give the speed actually.
The question is after deployment of PCS nodes, whether it will be created as roaming architecture, home routed, or it will come.
No, it is for home routed only. Home routed only for data services.
Because they are not depending individual MME for PLM.
No, each circle having its own MME. See, there is a huh?
It's a PLM.
Yes, that is the zone. Under those there are circles, and each circle having its own MME.
Virtual.
MME will be circle wise.
Yeah. So this is a case of local breakout. Now what happens in local breakout? Local breakout means service to be given from the local network to from the visitor network actually. So that is why it is called local breakout. Here you see the subscriber coming to the VPLMN and send the request to the MME. MME authenticate the service from the HSS. And this is the HSS actually. This is the HSS. There is a bit called VPLMN. This particular bit defines the roaming type will be what? Home routed or visited or local breakout. So HSS tells MME, okay, you can give the service from visited network on. So MME will tell as gateway to send a create session request to this visited P gateway. And service will and visited gateway, because visited P gateway don't know what QoS to be assigned for this particular UV, right? So P gateway, this visited P gateway will send a CCR, create control request to the visited PCR. Now, in case of local breakout, this visited PCR will talk to the home PCR and fetch the QoS defined in the home PCR for this UV. Got my point, na? So home PCR will give the QoS defined for this particular UV to the visited PCR, and in turn visited PCR will tell the P gateway, okay, for that particular subscriber, you have to give this much of QoS. So that is how local breakout works.
Can you explain?
Which one?
When we are using that one and when we are using
So this is not at present in India. It is not used actually.
concept.
Yeah, this is the only concept.
One
Sorry, this one. Okay. See, this. So this is the subscriber. This subscriber belongs to this home P11, right? So this subscriber from the home P11 coming to this B P11, and it sends the attached request to the inode B. So this the P11 of inode B is different of this P11 defining the EOE, right? So this inode B sends this attached request to the MME. MME knows that it is okay. This is not my subscriber, and from the P11 it finds that okay, I have to get authenticated from this particular HSS for the subscriber. So once authentication takes place, it is the HSS. You have to define the roaming type in HSS actually. So in HSS, MME get to know that okay, I have to give local service for that particular subscriber, right? So MME will send a create session request to S gateway and telling S gateway to select this visited P gateway for service, right? So once the request, this P gateway receives the request for the particular visited subscriber. Now what QoS it has to give, because it is don't know any QoS. So it sends a request to the PCRF to get the QoS defined for that particular subscriber. Now this PCRF this is called as S9 interface. This PCRF, this visited PCRF will send a request to the home PCRF, and from this home PCRF, it fetches the QoS data for the subscriber. And once it gets the QoS data, it simply informs P gateway that okay, for this subscriber, this much QoS has to be defined. You have to give service with that particular QoS. So that is what is local breakup.
Sir, in this local breakup, necessary signaling and
Basic advantage is basically because this is your subscriber and the QoS has to be defined in my HSS, in my PCRF. So from the PCRF I have to give the services. In case of local breakout, there is not guarantee of data. This although BPCRF get the QoS from the ACF, but it will give the service as per its own circuit design actually. It is not like that. Suppose in the home PCRF, for this particular EUV define 100 Mbps data. You have to give the speed of 100 Mbps. But it is not must for this visited network to give this QoS. So it is based on data means. So that is what is the difference basically.
We can say we can avoid the use of SIT interface.
Yes, here SIT
No need of SIT.
Yeah, there is no need of SIT, but S9 will be there between the PCRF.
That's fine.
S9.
S9.
Yeah.
No, the data that will be continued, it will break and it will
No, data will continue. There will be no issue. Yes. Yes.
So one more doubt, sir.
Mhm.
In IMS to IMS,
Mhm.
connect to network. Like that, all the ones IMS. Other POI also is.
I don't know.
So individual IMS
Do you have any idea how IMS networks are connected actually? I will please ask your question again.
The data, IMS council, other will integrate to other POIs.
Others?
See, for IMS to
Other
POS,
TSP,
okay, okay.
IMS.
Right now it is not connected because our IMS POS is going on Chandigarh actually, Ambala on. So one is get through, we have to install our IMS in the Chandigarh pass. Then we will install in subsequent places.
This question is at that time whether POA is also
Is there any plan like
point
that?
of interface is that?
That's nothing to do with
That I don't know.
That we don't.
It's a policy decision. If you want
That we
That
don't
I
know.
don't have any idea.
Now we are having. Because they want to extend the
IP.
I think for connecting to the legacy network, we're talking about legacy.
IMS.
IMS time. Yes.
you want to have a Geo user and BSNL user end to end
IBCF. There will be IBCF. Basically, that will be connected by IBCF only.
Whether that is there or not.
Oh, that I don't know.
That will be the policy design. I think that will be.
Right.
They are implemented.
So this is actually this is our IMS architecture. Very briefly, I will explain actually. See the entry point from the IMS. I already told you the PCSCF. So there are basically three CSCF kind of node in IMS. One is called P proxy. I is for interconnectivity CSCF, and there is service CSCF. And in the network there will be multiple SCSCF actually. So ICSCF is basically find out from the HSS that which SCSCFs to be used for this particular use. And there is a BGCF. I already told you BGCF is basically for connecting other IMS network. And application server is basically we call it TAS, telephone application server. And all the features like call forwarding, do not disturb, all these things has to be configured in TAS server only. And there is MDCF. MDCF is basically connected to the legacy switch. So very brief description of IMS. So this is the actually attached call flow. So these are the various nodes: UE, E node B, MME, HSS, DNS, S gateway, P gateway, and PCR. So now see, this is the UE. It sends an attached request to the E node B, right? So before that, actually, this radio connectivity has to be established between UE and the E node B, RRC channel, right? So once the RRC channel has been established, then UE sends an attached request to the E node B. Then the attached request is basically sends the IMC. TIE means tag plus PLMN, tracking area code, tracking area identity, right? So attached request it sends IMC and TIE and a PDN type. PDN type means whether only circuit switch required or packet switch required, or is a combined attach, or it is a EPS attach. Or what is combined attach and what is EPS attach? Anybody any idea?
Combined is both CS and
Yes.
DS together.
Yes. So there are two types of attach actually. One is combined attach, one is EPS attach. Combined attach means this MME basically this is for both packet switch and circuit switch. So MSC knows the location of the particular subscriber in case of combined attach. There is EPS attach, that means only IP. That is not MSC actually. So normally all phones sends a combined attach only. So MME sends the combined attach here. So E node B simply forward this attach request to the MME. Now MME has to authenticate. I already told you MME has to authenticate the UE. So this is the message. This is called it is called AIR, authentication information request to the HSS. So depending upon the keys algorithm, HSS has to authenticate to that particular subscriber. So already I explained you how authentication takes place. So once authentication is okay, then MME sends a user update locations. So here HSS sends MME that whether subscriber is prepaid, whether subscriber is postpaid, or what is the QoS defined for that particular subscriber. Everything HSS will tell MME. So once it will get the QoS and all this subscriber information, now what is the function of MME? MME has to select a particular S gateway or particular P gateway, right? So see, there may be, I already told you in the network there may be multiple S gateways. So each S gateway having its own particular IP. So in the DNS, there is a mapping between IP and the tag. So let me explain actually. And this is the enemy. And this is S gateway 1. This is S gateway 2. Suppose this IP is and this IP is right. And I already told you what is tracking area. Tracking area code. This has to be defined as gateway also. Suppose the tag is here, tag defined here is X and tag defined as fine. How enemy selects? This is the UV. UV sends a request with a particular tag. Suppose it is given take X, right? Now, and we don't have any idea about the mapping of tag and the IP. So it sends a DNS query to the DNS server. We call it enum. We call it enum. This is basically nothing but a DNS server. So here there is a mapping of tag X with S gateway IP 192.5.2. For Y it is 192.5.9. Right. So this is the 2. This S gateway IP is 2, and this S gateway IP is 9. So enemy sends a DNS query to enum with tag X, and enum sends a give the response to enemy. The for X you have to select this as gateway, like this. So now enemy knows which as gateway it has to select, this as gateway only. So it sends a create session request for PSR. So this is how as gateway is selected, right? Any doubt? So if you see here, similar thing happened for P gateway also. Just keep in mind that for S gateway is selected based on tag and P gateway is selected based on APL. Right? Like this is P gateway 1 and this is P gateway 2. So, like for S gateway, I told you that UV sends a tag request. UV also sends a APN name also, APN access point key. Like for data, in case of BSNL, it will say BSNL.net.in. For Geo, it may be Geo.in, something like that. So this is the data. This is the APN name for data service BSNL.net.in. Like for multi service, this is called IMS service. The APN name is for this is IMS one. That is fixed for all. So there are two APN basically. One is for data, another is for voice. So that. So now how enemy will select the gateway depending on the APN name. So it will send a request to your name with the APN name, and in enum there is a mapping of APN name to the gateway IP. Right. So here enum we have defined it for BSNL.in. This gateway IP has to be defined, and for IMS you can select this one also. You can select this one also. So it is configurable. You can select multiple P gateway depending on the APN, or you can select same P gateway for the multiple APN. So this is how S gateway and P gateway selected by the admin. This clear? Any confusion? Everything is okay. So right. So see once. See, this authentication takes place. ULA also completed. Now see, MME sends a DNS query to the enum. Right, this is the DNS query to the enum that I already told you. And from the enum, it able to find out the S gateway IP and the P gateway IP, and then MME sends this create session request to the S gateway. Now, what is create session request? Create session request is basically request for a create a logical channel for the particular subscriber. Right. in the data channel. The signal is going via MME as gateway C as P gateway C, but the data will be going by the P gateway DPs. So there is a logical channel that has to be configured. That has to be configured in the DPs actually. Right. So these are the. This is create session request is basically request for to create a logical channel in the data path. Similarly, as gateway sends this create session request to the P gateway, and P gateway sends a credit control request to the PCRF to find out the QS. That's I already told you. PCRF in turn sends this credit control answer to the P gateway with the defined QS, and then P gateway sends a create session response to the S gateway, and then S gateway sends a create session response to the P gateway. Similarly, S gateway again sends this create session response to the MME, and in turn MME will send attach complete request to the EUV. Then in turn InnoDB will send the attach complete request to the MME. So in that case the attach is complete. Now EUV can able to access in turn. The logical channel has been formed. So any doubt about call flow? I've explained simply data call flow actually, not IMS actually. Right? So this is the basic how our EMS elementary management looks like this actually. When you log into our EMS, it will be look like that only. Tomorrow there will be a live session, then you can find out more on this. So in the dashboard you can see there is a provisioning. This is the provisioning. So if you click the provisioning, there are managed nodes. So if you click managed node, whichever nodes discovered in the particular EMS, that will be displayed. Like if you see the first node, that is called Day-1 PCRF. That means you can define any name actually. This is the node name actually. You can define any name as per your choice. So we define this Day means Delhi actually, or Val means validation. Right. So Day-1 PCRF. So node name is basically the PCRF. So now there is a MME, there is HSH. So these are all the discovered nodes in the EMS. The two nodes are showing in the red in critical. That means this particular nodes are down. So from the centralized EMS, you can find out the status of our core network.
Here, show as a SW and SW separate.
Yes. One thing I forgot to tell you. Yes, you are correct. In CRAFTS architecture, there will be one CP as gateway in activation by, and in one CP there will be 9 DPs maximum. Right. There is one CP means as gateway in active by standby mode, and in one CP there will be 9 DPs as gateway DPs for load sharing. I'll show you. So all DPs are independent. They are different nodes actually. They are different VMs, virtual module. So CP is a virtual module. VM, this DP is also a virtual module. So in one CP means one P gateway CP, there will be 9 different DP because maximum load will come into DP. No. So this 9 DPs is basically for the load distributions. You can configure the DPs as per the tag. Suppose some attached device coming from the particular tag, you can select a particular DP for this. So DPs are selected depending upon the tag received from the UV side for the load distribution.
One CP is one SWC instance or
instance. One active means one active as gateway means one instance. One standby as gateway means another instance. So 2 instances will be there in active standby mode for single as gateway CP.
So we can duplicate from that. SWC showing a same.
No, it is not same. E gateway is a different node, as gateway is a different node.
SWC, SWU,
they are different nodes. They are different nodes.
You know, PGW, CP, PGW, HGW.
See, this is the DP node, P gateway DP, right? And this is the P gateway control plane actually. This is the P gateway control plane, and this is the P gateway DP. So we have in this diagram, in this actually EMS there are only one DP. So we are showing it 1-1 actually. So it can be 9 DPs also. See, this is the P gateway. Yes, your question will be answered here. This is the P gateway, how it looks like. This is the P gateway C. And this is an active mode and standby mode. These are two separate instances. These are two separate VMs, right? So this is a single P gateway in active and standby mode, having two instances. One is for active, another for standby, and there may be 9 DPs. See, this is a DP1, DP2, DP3, DP4. Since I have not configured these DPs, so no DPs are showing here actually. Otherwise, you can have 9 DPs for a single S gateway CP.
On main data center. One will be PR as well as PR and GR as well.
Yes. That is not related to PRGR. These DPs are basically related to the CP, P gateway CP actually. Yes. See, these are the IPs actually. These DPs are basically, you can distinguish by the IP itself, because 9 DPs are having some different IPs. So all these IPs you can configure in a single CP. So this is how our node looks like. This is actually PCRF actually, active standby mode. And from this window, we can find out how much CPU uses are there, how much memory uses are there at that particular time, and what is the total memory allocated for that particular instance actually. And this is the software version actually. This is the EMS. This is the EMS, and I have selected particular node info. There is a one parameter called node info. So if you just select that particular node info here at Fusion PCRF, so if I select that particular PCRF, this window will come, and from there you can find out whether this active is working or not. Green means it is working. If there is red, that means it is not working. Right? And how much CPU uses are there, how much memory uses are there. So you can find it out. Yes, for app caps also. For app caps also. Yes. Yeah, for S gateway, even for P gateway, DPs are always in mini DC only. Right. CPU will be in your main DC, and all DPs, including S gateway and P gateway, in the mini DC. But you can configure 9 separate DPs for a particular single CPU.
The same one CP, is there visual between PR and the GM?
No, for they are two different actually. Even this, they are the separate nodes actually. In the PR, like there is one P gateway, there is separate P gateway in the GR. It is not like that this P gateway will be used in the GR also. There is separate distance in the GR actually. Redundancy will come into picture when PR will be going down actually. When PR will be going down, then GR will be comes into picture.
Going down means it is totally not reachable in the network. In that case, on
one reference point here. This SXA, whole one reference point. 6 AR by RC. C and both SWC, SW, SW. So how you are managing that? How you are arranging?
See, we actually this GR concept we are still actually in the design state actually. It is not implemented in BSNL right now actually.
but MaxNG वाला concept जो
Max NG में कोई भी node down हो जाता है simple है. So in our case, if any node goes down in the PR, automatically GR
any major node.
yeah, any major node, then GR will be active. Suppose P gateway of the main PR goes down, automatically whole PR will be going down actually. So GR will come into picture.
One CP, whatever the handle is, that's fine. So there.
See, in the PR there is also a active standby option. So suppose actually what we have did actually in active standby mode, there are basically installed into separate servers. In the cloud, you can define a zone actually. In compute, it's called compute actually. So the one copy is in the one active zone, and another copy which is standby some other zone. That means in other server. So in any case, in PR, if one server goes down, the standby will take care. No, if the main DC fails, If the main,
DC and mini
Main and
DC.
mini DC. The basis main.
okay, main DC and mini DC.
That PLM and services will go down.
HPR will come.
No. Then the service will be hampered. Okay, you are telling that your P is down, but DP is up. It is like that, no? In the PR, P gateway CP is up, but the DP is down.
DP fails.
Yeah, no? So in that case, I think the service will be hampered. Service will be hampered actually.
For main DC, GR is there,
Yeah.
not for mini DC.
Mini DC GR is only for the load sharing.
Actually, GR I think we will explain later on actually, because
That's very sure. If
Another point is that
mini
how
DC
he is asking that your main DC PR is down. How the MME will know and how it can route the drop selected GR.
okay. Right. Actually,
Then
there is one
normally we
component
used to have
actually. Yeah. There is
virtual
one
IP concept.
Yes.
Active node one IP, standby
Floating
one
IP.
floating IP. The other node will always route the traffic to the floating IP. So if which one node is active, then automatically.
Right.
Like that, any concept is asking.
Actually, in our Max AG, there is a one node actually. I forgot it. That node, as we know, that node basically talks to the peer node as well as peer node also. So it knows the health status of peer
Like
node.
that, some
So as soon as this goes down, automatically it will fire the
traffic will be
yes.
entirely routed to GR.
But in case of 4G, actually, I don't know actually. It's in the planning stage.
The same 1+1 primary part and take path. So my physical path is down. Whether my GR path will take care of my.
No, I don't think so.
That will not happen. That will not happen.
Service will be hampered.
For that particular PLM and service will be hampered.
And then the configure both the GR and the primary will active.
No, that will be not active. That is actually active and standby mode only. Not active. See, I think for GR implementation, I will come later on actually, because
No, that discussion is going by the 50% load sharing basis active. That concept is there.
That is still in the planning stage actually. Right.
That is not yet
So-
finalized. When it will come up, that time we will know whether it's active or purely active status.
The implementation is not yet reached actually.
The 50%
That is active.
That implementation actually is still in the progress actually. So once the final, then I can tell you actually.
instead of center.
Right, I got your point. Right. I got your point. So these are the various alarms and events in the EMS actually. So all this F caps you are talking about. So this is the faults and events that is coming to our centralized EMS. From this you can find out which node is down or which are the alarm that is still in pending in the port. In the EMS, there is one option that is called EMS EPC performance report. So here you can find out that how much MC is attached in a particular time, right? How much CPU uses for a particular node, how much RAM uses a particular node, and how much this combine attach, how much attach is failed. All these performance reports are there in a particular. Tomorrow, the online class, we will explain more on this. So this is it is called statistics. This comes under statistics. Actually, you can find out this today, yesterday, last 7 days, or you can customize date also. You can select a range and you can see the status of various nodes. This I already explained. See, I already told you about trail and tag. See, here you can find out this. This is the tracking area code 12594. So 12494, I have mapped with TAL 1, right? 12596, I have mapped with TAL 2. So this is the screen actually where using which you can configure the tag under a TAL actually. I think it is not possible to do more than this. We'll give you the PPT. We'll give you the PPT.
Here we can.
Now it is clear. So this is the tracking area and this is the tracking area list. So using this particular option, you can select tracking area and you can configure tail actually. So I already told you now, in case of P gateway, the main function of P gateway is to basically to allocate IPs for the UEs. So here you can see this is the P gateway actually. It is called NAS pool actually. This is the P gateway EMS actually. Here see this is the NAS internet. That means it is a data service and it is for IMS service, right? So for data service, we have defined this is the IP range 50.0 to 48.1 to this one. That means total 255 IP can be allocated from this core actually, right? This is the IPv4. This is for the data network and this is for the IMS network. So these are the pools. How this is the P gateway, and this is how we can define the UE pools for the particular UE. So this is the IPv4. Similarly, you can define IPv6 also. So this is the end of my presentation. Thank you. Any question you can ask. This is the public IPs actually, but there is a device called CGNet. In the CGNet, you can just you can map from by this private IPs and public IPs. Actually. So that is the different node actually. That node basically doing the netting functions. So here you can define any IP, whether it is a public or private, it doesn't matter.
Sir, is there any plan to integrate existing?
Sorry?
Any plan
To upgrade to 4G.
3G data traffic also.
So 2G, 3G data communication is still there.
Yes.
Right now in Chandigarh, actually, S4 is not required. Actually, yes, we are basically using GNGP interface because our whenever our subscriber goes to 2G, 3G, if there is a node called LGSN, so it will go to the LGSN. From LGSN, it will go to the SSTP. Then the order for SSTP, and from the SSTP, it will come to our AGSN for authentication. Right. Once it's authenticated, then this LGSN will send a case certificate to our P gateway, and from P gateway it takes the service. So S4 is not coming to picture. This interface is called GNGP interface, GN interface, LGSN and our P gateway. So for now, this for handover from 3G, 4G to 3G, the GN interface is used, but not S4. S4 is not required in our system.
Once we deployed in our network,
Then it is required.
we want to shut down our.
Then it is required. Then LGW will talk to LGS.
Sir.
Hello.
Hello.
Good afternoon, everyone. So I am from the router and switch team. So our presentation will be on the data center architecture for BSNL 4G deployment. So in our presentation, the main focus will be on leaf and spine switches. So this is the agenda for today's slides. So first, we will have a brief overview of the C.4G EPC core architecture. Then we'll head towards the data center, BSNL 4G data center realization, data center switch fabric architecture. And then we will come to the EPC core connectivity and the different components, the data center hardware components, high availability architecture, the physical connectivity, the management switch connectivity, the 25G connectivity of the CP servers, the server and leaf spine 100G connectivity, spine to PE router connectivity. PE router here refers to the routers used in the BSNL IP MPLS network, the underlay and the overlay networks, fabric connectivity, the different routing and switching protocols used, main and mini data center, typical data flow for internet PDN, geo redundancy architecture and requirements. Okay.
He's ready.
Okay.
नहीं लास्ट नवंबर मीटिंग ये हो जाएगा तो सबसे बेस्ट है राइट फ्रॉम द स्टार्टिंग सबसे बोल रहे हैं Right. This is a normal. Then against then it goes to SS goes to HLR via SS. Right. In when their HSS replaces ZTHSS. Right. This HSS replaces ZTHSS. The same function will be done. At HLR part, HSS, they are yes, yes. For that, they have to do migration in current 9.2. For the solution, we are having single HS and HLR. Currently, the HLR is separate. See, will be the main two major difference. In existing method, HLR is in upcoming management. Total Stop. That is the first party. Stop. Yes. Currently, we are having the last one family will be provided with Everybody has got.
Yes, yes.
So I will be covering the slides from the starting to spine to provider edge router connectivity, and the rest of the slides will be covered by my colleague Himanshu. So firstly, a brief overview about the EPC core architecture. We have already gone through it, but a brief overview of it. Converged virtualized 4G, 5G, NSA, EPC, IMS core. So converged here refers to we provide everything within a single package. Virtualized means all the EPC nodes are launched virtually. There is no separate hardware for it. And 5G NSA means 5G non-standalone. Non-standalone means we have a separate RAN which supports 5G, but the core is basically of 4G architecture. It's COTS equipment. COTS means commercial off the shelf. There is no dependency on any particular type of hardware. That is its proprietary hardware independence. It runs on a single zonal private cloud. Every zone has its own private cloud, and the infrastructure manager within a cloud can launch VMs only within that zone. It has distributed core with control and user plane separation. So as we have already studied earlier, the main data centers will contain the control plane server, which consists of MME, ECRA, HSSS, whereas the mini data centers will contain the user plane or the data plane servers, like the SGW or PGW, DPI, NAT, etc. It's highly available because multiple servers are there and multiple servers are running multiple instances of various EPC nodes. Scaling, so say if the subscriber or the load increases, we can run another instance of the EPC node on another server or on the same or another server. So horizontal scaling is supported based on load. Mobility, say if some of the EPC node crashes, we can initiate another node instantaneously within the same or different server. ECMP based load balancing. ECMP refers to equal cost multiple path. Suppose from source to destination, we can have multiple paths. So instead of utilizing one path, we will share the load among the various links, and there can be optimal link utilization. This is the basic diagram. You can see on the right hand side, you have the EPC core components, and on the left hand side, you have the UV, which is connected to the BSNL transport cloud via the eNode B. And in between, you have the data center where we will be looking about the leaf and spine switches, which are used for the interconnectivity between the EPC core components and the BSNL MPLS cloud. So BSNL 4G data center realization, C.EPC is deployed on commercial off-the-shelf components. C.EPC nodes virtualized instances. VNF, as we know, it runs on OpenStack, and CNF runs on Kubernetes. They both run on COTS servers. C.data plane nodes are hardware accelerated. They have the support of SmartNIC 100G cards. High capacity switches are used for leaf spine switch fabric. So the leaf and spine switches, each of them, the ports have the capability to support up to 100G bandwidth. That's why we say they are high capacity switches. Management switches are deployed for 1G connectivity of servers and leaf spine switches. So for the out of band management, for accessing the servers and the leaf and spine, we have a dedicated management port for out of band management activities. So that 1G connection is done on a separate switch. That is the management switch. Leaf and spine switch that will come, that leaf and spine switch is basically an architecture which follows the CLOS architecture, which is deployed in various data centers. We'll come to that in the next slides. So this is the switch fabric architecture. This is a CLOS architecture. It's a multi-stage non-blocking architecture which is followed in various data centers. It has various advantages that we will see. So both the spine and leaf will contain switches, high capacity switches. Okay. So the leaf portion, the leaf switches will directly connect to the servers, and the leaves will be connected via each other by the help of the spine. The spine will form the backbone of this architecture. No two leaf will have a direct connection. So for any two leaves to be communicating with each other, they need to communicate via the spine. So in this particular case, it's a two-tier architecture. That means each nodes are maximum 2 hops away. By hops, I actually mean the links. One link is from this leaf to spine, and then spine to leaf. So you can see there is a deterministic latency over here, low latency, that is only 2 hops. Leaf switches provide layer 2-3 connectivity to servers. So all the servers that are connected to the leaves, they belong to particular VLANs. So layer 2 because of the VLANs, and layer 3 because we have assigned particular IPs to these VLANs for inter-VLAN networking. So we provide both layer 2 and layer 3 connectivity. Spine provides connectivity between leaf switches. So for leaf 1 to communicate with leaf 2, it can only traverse via spine. It cannot comment. There is no direct link between these two leaves. Leaf switches connect to each of the spines over one or more layer 3 interfaces. So whatever this leaf, take for example, it will have connection to each of the spines. So there are 4 spines over there. So there will be 4 links to each of the spines. Again, in this particular left-hand side leaf and left-hand side spine, you can see only one link is there. But for redundancy and bandwidth utilization, more than one link are present in our architecture. So there will be more than 2 links over here, as well as the second spine, third spine, and fourth spine. Uses IP ECMP for non-blocking active-active architecture. So ECMP, as I have mentioned, like when, say, suppose it has to send some load, it will send it using multiple links and it will distribute the load. It will not send it on a particular interface. Rather, it will distribute the load between the various interfaces. Scalable architecture. So since the servers are connected directly to the leaves, and whenever there is requirement of more servers, we need to add more leaves into this topology. And for increased capacity bandwidth, we need to add more switches. So this solution, as we can see, is scalable, optimum link utilization because of ECMP, predictable low latency because each node is only 2 hops away, and high available data center because there are multiple leaves, multiple spines, as well as the link between the leaf and spine are more than one. There also, we are providing redundancy at link level as well as a node level. Now we'll be studying about the DC hardware components. So the Dell server model, we have the servers which are of Dell, and the model number is PowerEdge R750. So in case of the data plane servers, we have 100G smart NIC cards, 200G smart NIC cards. And in case of control plane servers, we have 2 into 25G ports, which are used for signaling traffic and inter-EPC code connectivity. Besides that, for management purpose, one, we have ID rack RJ45. This is used for the physical server, for the management of the physical server. And besides that, we have 2 into 1G RJ45. These are used for the OpenStack and Kubernetes connectivity. So this is the management switch. So this again belongs to Dell, and it's 1 rack unit form factor. It has 48 into 1G RJ45 ports. And here, yeah.
In case of mini DC, 2 into 1G.
In case of mini DC, only the data plane servers are there. So 2 into 100G smart NIC cards servers will be
sir,
there.
this 2 into 1G is for
2 into 1G is
for
required
management purpose.
for management purpose. This is not for data flow.
That is data flow.
For accessing the Kubernetes or the OpenStack, we need the management connectivity. Yeah.
Sir, at mini DC also this is required.
So for accessing or configuring anything, we need this, the ID rack and 2 into 1G RJ45. So it's 1 RU form factor. It has 48 into 1G RJ45 ports. So all the 1G management ports that of the servers or of the leaf and spine switches, those will be connected to this 48 into 1G RJ45 ports. And in addition to that, it has 4 into 10G SFP ports. So out of these 4 into 10G SFP ports, 2 of the SFP ports will be going to the leaf switches, which will be used for connectivity, which we will be seeing later. and it has 1+1 AC/DC power supply unit, 3 fans, 800 million packets per second processing capacity, and input-output to power cage airflow, that is the air flows from front to back side.
What is the purpose of tennis in case of management?
10G is not used for management. 10G is used to directly connect the management switch to the leaf portion, to the leaf switch.
All the management servers are being uplinked to leaf switches. So for that, 10G is being used. So every rack
will have a separate management.
platform. Basically, it will be
Yeah.
Yeah, so all the servers present in a particular rack will be connected to this management switch, and one 10G link will be gone for connecting all the servers management to be uplink to the leaf switches. That will be.
So from the leaf switch, we can connect to every server and every other leaf and spine.
In the network, total 6 switches are.
Total?
In the network, total 6 switches will come.
Switches.
Switches.
Sir,
to management switches to leaf to spine.
Actually, in the mini data center, it will be 2 leaf, 2 spine. So according to the architecture, in case of the main data center, it can be up till 3 leaf switches.
Servers will also be directly connected to leaf.
Server 25G ports. The 25G ports in case of CP servers, and in case of DP servers, 100G ports.
Yeah.
So management switch, the management ports will be connected, and for signaling, we have the 25G ports that will be connected directly through the leaf, and for data flow, 100G of the data plane servers that will be also directly. So for management purpose, whatever 1G is being connected, that is why the management switch to the.
So that topology will come later after some slides. There are topology for that.
So now this is the architecture for the leaf and spine switch. It uses HP hardware with CDOT router OS. So it has a total of 32 ports. Each 32 port can support up till a maximum of 100G capacity. So it can be configured either 100G and 40G. So here we have the concept of breakout ports or breakout cables. So using breakout cables, we can have 100G connection at our router end, and then we can bifurcate into 4 different channels of 25G connection each. So from 100G, we are getting 4 25G connections. And similarly, from one single 40G connection, we can get 4 10G connections. So if there are a total of 32 ports, so we can divide it into, we can multiply it into 32 into 4, that is 128 into 25G or 10G ports, or 32 ports of 100G capacity or 40G capacity. Okay, so we have a total of 32 ports. Okay, so each can be configured either in 100G or 40G. Okay, so suppose in case of 100G, we have also in case of 40G, we have the provision of breaking out. Okay, breaking out means we can divide the interface further into many interfaces. So we have something called as a breakout cable. So on the router hand, we are using a 100G connection, 100G cable. And then we have a breakout cable which breaks down into 4 25G connections. So at the other end, we can connect to 4 different devices of 25G each. So similarly for 40G, we can connect to 4 10G devices each. Yeah, breakout, yeah, different equipment. 3.2 Tbps, that is true. And also if you divide it into 4 ports, it will be 128 like this. So it has a separate console port for management, and also an out-of-band management port that is of 1G. It has dual AC power supply, 1+1 redundant, rear FRU field replaceable unit. It has 4 hot swappable fans which with N+1 redundancy. That means at a time 3 fans needs to be working properly, front to back airflow. There are status LEDs for system health, PSUs, fans and ports. 3 Tbps full duplex throughput, as I mentioned earlier. 4.7 billion packets per second processing capacity. 400 watt typical power consumption. This is the maximum power consumption. In case of Chandigarh Main Center, it is around 200 to 250 watts power consumption is being used. AC/DC is both.
Power supply. Yeah, depending on the power module,
we can use
DC
both. Yes, sir. Yes, sir. Mini DC.
Yes.
Yeah,
Yeah,
these are used in Mini DC as well as Wind DC.
Plus from 5 kV.
Yes.
Yes, of units.
But that UPS capacity that 8 people will, you know,
Okay, so these are some of the software features that are supported in our leaf and spine switches. For the L2 features, we have MAC learning. So like any other switch, it supports the MAC address table, which contains the MAC address, the interface, and the VLAN. And it also supports VLAN and IRB support. So we can assign IRB is integrated routing and bridging. So we can assign IP to VLANs, and we can support inter-VLAN communication with the help of IRB. Link aggregation. So suppose in most of these cases, you have seen from leaf to spine, we have multiple connection, more than one connection. So what we do is that we group all these links together to form a single link, which acts like a single link. So we will have more bandwidth, as well as there will be trunking. Yeah, trunking. And also there will be redundancy. If one link goes down, it can switch over to the other link. So this, we are using a protocol called LACP, Link Aggregation Control Protocol. Spanning tree, in case of some of the L2 networks, we have the tendency of forming loops. So different protocols like STP, RSTP, MSTP are used to block the redundant ports so that no loop is being formed. MCLAG is multi-chassis link aggregation group. So just like in link aggregation protocol, we have the redundancy of links. So suppose if a whole node goes down, then we cannot do anything because the links will also go down. So in case of MCLAG, we have the redundancy of nodes. So instead of redundancy of links, we are also providing redundancy of nodes so that if one node goes down, the load can be switched over to a different node. IRB is integrated routing and bridging. So VLAN, basically we know it belongs to layer 2 domain, right? But we can assign IP address to this VLAN so that different hosts belonging to different VLANs can communicate with each other. So inter-VLAN networking is done via the help of IRB, and we provide IP addresses to VLANs via this feature. MCLAG, sir, suppose we have two nodes, A and B. Okay. So suppose we have two links between them. Okay. So suppose what if node B totally goes down? Then there is no help of keeping those two links, right? All connection depends on in this architecture, actually, we are not using MCLAG.
So in this, basically in this data center architecture, we are not using MCLAG.
But just for the feature purpose, I can explain.
Actually, some other technology has been used that has taken care of this MCLAG also.
So these are two devices, A and B. So we have two links between them. Okay, and we have formed a lag. So say if this node goes down, all the traffic can be switched to this. If this link goes down, all the traffic can be switched to this link. Okay. But what if this node goes down? So there will be no value of these two links, right? So instead of that, what we do is that in MCLAG, this here we form a bundle, and these are the two MCLAG peers. So if B goes down, the traffic can be routed through C. So there are two links at A side, and there are two different nodes at B and C. So if one node goes down, the other traffic can be routed through the other. L3 feature, so it supports both IPv4 and IPv6 routing. So it supports static routing, and in case of IGP, it supports OSPF and ISIS. In our data centers, we are using OSPF as the IGP, Interior Gateway Protocol, and BGP, that is Border Gateway Protocol, it is used as the EGP. It is used between our spine routers and the PE routers of BSNL. We also have support for VRF. VRF is virtual routing and forwarding. So in a router, basically, we have one routing table, but VRF is the segregation on L3 level. So suppose we want multiple routing table and we want multiple instances of routing protocols running within a single router. So for that, we implement VRF. Right now, sir, whatever leaves and spines we have used sub interfaces. There we haven't used VRFs. According to the architecture, there is VRF on the BSNL side, and corresponding to it, we have used separate for each VRF. We have used a separate sub interface, and we have used NNI option 1, option A that will be explained later. We haven't used VRF as of. BFD is bidirectional forwarding and detection. So BFD is a protocol which is used for faster convergence time. BFD packets are run between two peers, routing BGP peers, which senses whether the link is up and down. So if the link goes down, it will help to detect it very fast because it sends packet every 300 milliseconds. And so we can have a faster convergence time using BFD. BFD, both. Yeah.
Sir, BFD is at the protocol level. LSCP is the picture of L2 level. So there are different features.
BFD will be used along with routing protocol. Say you have BGP. So for the faster convergence of the routing table, you are using BFD on BGP. So which side, sir? E-Node B.
Sir, actually connectivity of the spine is with the PE router of the BSNL. So the communication that is VRF coming onto the PE router is taken care by sub interface at the spine router end. So as such, no physical connectivity, direct connectivity is with E-Node B side.
QoS is quality of service. That means we differentiate various service based on the priorities. Then we have policy-based routing PBR. Generally, routing is done based on the destination IP address. But suppose we need to route some packets based on different IP headers, like say source IP address or source MAC, DMAC, or TCP or UDP port, then policy-based routing can be used. We have the support of NTP. With our routers, leaves and spine switches can synchronize with the NTP server. Also, we have the support for VRRP. VRRP refers to Virtual Router Redundancy Protocol. So in this case, we have the redundancy in case of gateway routers. So if for the uplink traffic, we can have more than one router. So one is set as the active and another one is set as the backup, and they will communicate with each other. Next is the EVP and VXLAN technology. This we will be going through in details in the later slides. So what is EVP and VXLAN is basically the extension of layer 2 technology over a layer 3 network. So suppose in our case, we have multiple servers which have the same VLAN configuration. But those servers are connected via layer 3 network. So how to extend this VLAN, that is L2 information, over this L3 network? In this case, this technology EVPN comes into the picture. We are extending the L2 information such as the VLAN, FDB MAC address table across the servers which are on a L3 network. So in this technology, we are using EVP and VXLAN. Management and monitoring features. We have CLI, SNMP, NetCon for EMS and REST API. Fabric monitoring and visualization. We have a tool called Grafana, which we use to maintain the topology as well as the CPU and memory utilization and the various critical processes, the status of various critical processes. Syslog, remote software upgrade, local and remote port mirroring. We can mirror the traffic coming to a particular port to another port to analyze the traffic. The source port and destination port can belong to the same device or different device. S-Flow. S-Flow is a technique by which we sample the real-time traffic and we collect it in a different S-Flow server and we can analyze the traffic from there. uplink failure detection. So in this case, uplink failure detection, we define a special pair of uplink and downlink. So suppose if the uplink is down, we automatically disable the downlink so that no network resources are being wasted. So no traffic is being sent by the downlink pair. We make sure that if the uplink is down, we will automatically disable the downlink as well. Security features, we have the provision of supporting radius and TACACS. So our router can integrate with the radius and TACACS server, and based on that, we can have external authorization, authentication, and accounting. We have the provision of SSH, ACL, that is access control list. We can filter traffic based on different parameters like source IP, destination IP, source MAC, DMAC, and TCP UDP ports. Management VRF. So as I have told, VRF is the separation on the L3 level. So management port, whatever management ports we have, it belongs to management VRF, and data ports belong to different VRF. So they will have different routing table. So if there is load, say there is a lot of load on the management VRF, on the management port, the data ports won't be getting affected because they belong to different VRFs.
Security wise, actually, 18 has been completed, right?
Some of the test cases of security test cases has been taken care in 80.
I think that like actually last year there was an target implementation.
Oh.
Mainly for the router switches and servers. They have given some recommendations. But is it implemented? I don't know the project stage.
Sir, actually, we actually.
Actually, the size of the logs.
Sir, we will ask our team whether that.
We support both version 2 and version 3 in case of SMS. Yeah, we support syslog. We can configure a syslog server and we can send all our logs of the switches. How many?
How many years?
Said that I have to check with the design team.
Not 1 year online, 2 years off.
Okay.
So that requirement will check with whether that has been taken care or not. See, yes, sir, it is UI based monitoring.
But for now, in Chandigarh, syslog is being used for monitoring. We can provide the provision. Next is control plane protection. So whatever control plane traffic is being received at the router end for local consumption, we can rate limit there. Otherwise, there can be various DOS or DDoS attacks. Fabric monitoring and visualization, that we have a separate tool called Grafana, which is REST API based. So we can monitor the whole topology, the CPU memory utilization, as well as the status of critical processes. That is GUI based. Grafana. So 4G data center high available architecture. So at the access side, you have the servers. So the servers are with dual ports. Say suppose in case of CP servers, you have 225G ports. So 125G will go to one leaf and the other 25G will go to the other leaf. And both these 225G links will be in bundle mode, that is lag mode. dual links from servers going to different leaf nodes, active-active redundancy. Management switches are deployed in pairs with redundant links. So in case of management switch, we have the provision of stacking. So two management switches can be stacked with each other with the help of 10G interfaces, and both the Dell management switches can act like a single management switch. So in Chandigarh right now, dual stacking is being used. Leaf switch redundancy. Servers are dual home to different leaf switches, as I have said. One 125G connection to one switch and the other 25G connection to the other switch. Similarly, in case of 100G data plane servers, leaf switch to spine link ring redundancy. So again, each leaf is connected to each spine, and each leaf is connected to each spine by multiple links. Spine switch redundancy. So again, each spine switch is connected to each leaf with multiple links. So, and in case of spine to provider edge router, we have already two spines. So we have redundancy at the spine level, as well as the connectivity between the spine to P routers, we have multiple links. So there is link as well as node level redundancy there as well. We have two spines. Say S1 is a spine, and S2 is a spine. Here we have the provider edge routers of the BSNL. We have say leaf 1 and leaf 2. So again, there is multiple links between here as well as here. So this is forming a bundle or a lag. And similarly, from leaf 2, there will be redundant links to server spine 2 and spine 1. And there is an interconnectivity between spine 1 and spine 2 because all the routes that are learned from the provider edge routers are being transferred to S2 as well. Now say suppose you have a city server with you. 125G will go to L1 and another 25G will go to L2. Then you have the management switch with you. So the two 1G connections of the controllers, that is the OpenStack and Kubernetes 1G will come to the management switch, and the other IP rack for the server. This will also come to the management switch. Similarly, the management port of leaf 2, this is the management system will come to NGMP switch, and this is the management port of L1. Similarly, management port of spine 1 will come to management switch, and management port of spine 2 will come to management. And there are two TNG connections from this management switch. One will go to link 1, this is TNG, and another one will go to link 2. This is also TNG. So in case of DP server, instead of this 25G, we will have direct 100G connection. Yeah.
The leaf 1 and leaf 2, whether they are interconnected?
No. All communication will be taken by a spine. Because Sir, this is the basic cross architecture which we have. Actually, in cross architecture, there is no interconnectivity between S1 and S2 as well. We are connecting it because it is connected to the provider as well. So all the communication between the leaves in the standard topology, source topology that we use in data centers, the communication will be via spines. No direct connectivity. Yes. This one. So because otherwise 1G we will be wasting the resources over here. 1G each management port of spine and lift is 1G. So we have connected all the 1G to among the 48 1G ports we have connected. In the management switch we have more 10G ports. Okay. So out of the two 10G, one is lift 1, lift 2. These are the data ports. So we can configure it up to 10G. So if we bring one other 1G to this L1 or L2, that will be we will be wasting the resources.
Sir, also we are actually sir, also we are accumulating all the management to the uplink. That's why we have given it as a 10G.
Sir, S1, S2 also not connected.
S1, S2 is in the standard topology, it is not connected, but here it is connected because whatever BGP routes will be learned from E, this will be transferred by IBGP to this S2. In case a S1 goes down, it will have all the routes to the BSNL IP MPLS. Just trying to live right now, IGP, we are using OSPF. Yes, sir? No VRFs. No. Normal and global VRF, we are using OSPF. So here, management switch, you can see at the bottom, two 10G connections. One is connected to lift 1 and another is connected to lift 2. Now, here you can see something called as a breakout box. So what is a breakout box? At the leaf end or the spine end, we only have 100G connection or 40G. So 100G connection will come out to this breakout box, and then there will be other 4 corresponding ports of 25G each. So 225G will be going to 2 servers and likewise. So whatever 100G port you have, you will divide those one port into 4 different ports, and this will go to 25G ports of 4 different CP servers. And in case of DP servers, 100G connectivity, we can directly have it with without using the breakout box because it is direct 100G connection. In case of DP servers, we can have the direct link between the DP server and the leaves. So any doubts regarding this diagram? Any problem? No, management switch, again, management switch, different management switch is presented everywhere, okay, and it is used in stacking mode. So here you can see a single management switch, but actually 2 management switches are used, and there are different stackable 10G ports for that interconnectivity. So they are stacked one on top of each other. So actually, instead of 48 1G ports, we are getting a 96 1G ports. That is how it is used in the data center.
And sir, one 10G link is going to one leaf and another 10G is going to another leaf. So redundancy is also maintained at that.
No.
In this diagram,
it is
some
single,
links
but
are missing for complexity, but 2 links are going basically. One for leaf 1 and another 10G is going for leaf 2.
Okay. But the management switch itself, we have more than one management switch which are stacked together. For simplicity, we could not show it in this diagram, but in the data center, in each rack, we have 2 separate management switches which are stacked and form a single entity. Because a 25G connection, no? Yeah, because at the server side there is 25G.
And DP servers are basically used in 100G for communication. DP servers. Yeah. 100G is not for CP servers. Internal CP communication, SCP DP, some nodes are there that CP wants to communicate with DP. So it will basically breaks out 100 into 25G ports. 425 individual ports are there.
So a single port can support either 100G or 40G. So with the help of breakout 100G port, you are getting 4 different 25G.
On a 14 round showing 7+7.
Yes, sir. This is a just for the diagram 14 servers are showing. It can be more or less, like this is not a particular thing. Yeah, this is not a particular thing. But this diagram is actually not complete because of the complexity we could not show the entire diagram. Many things are missing in this. But this is for simplistic purpose. From DP server, so it is EPC. Yeah. Okay, so management switch connectivity, which we have the server ID rack port 2 into 1G RJ45 ports, out of band management ports of leaf and spine switches, which are connected to the Dell management switch, and we can connect. Say we want to connect to any of the server or spine or leaf switches. We can directly connect our laptop to the switch, and we can place it in the same VLAN, and we can access the management ports. Management switches are deployed in redundant pair and connected with each other through 2 into 10G short-range multi-mode optical ports. So as I said, 2 management switches can be stacked with each other using 2 into 10G ports. And stacking means they will act as a single entity. We can configure them using a single CLI. Management switches are connected with leaf switches through 2 into 10G short-range multi-mode optical ports. L3 gateways are configured on leaf switches and used for OpenStack controller and compute connectivity, out-of-band management communication, and iDirect. So whatever 2 10G ports from the management switch, you can see that we are going to L1 and L2. So whatever servers are connected through leaf 1 and leaf 2, the gateway of the servers are the leaf, are the interfaces of the leaf. So we have connected them via VLANs, and we have assigned IP to these VLANs. So whatever IP the VLANs have in those particular L1 and L2, those will be the gateway in the corresponding CP and DP server. So when the CP or DP server needs to send some traffic outside, always it would be routed via the leaves. So whatever, so suppose this 25G, this belongs to VLAN 25. Okay. Suppose it has a particular say 14.P/24. So it will, this port also will belong to the same subnet. So suppose this node, if it needs to send traffic outside this to the BSNL MPLS network, whatever traffic it will be sending via this gate. And this gateway will be the IP address of the VLAN assigned at the leaf. From here, whatever it is attached, it will be the IP address of this VLAN. So this will form as the gateway. So whenever it is sending traffic to an outside network, it has to route via this network. So this is the server 25G connectivity for the control plane server. So as I said, we have used the breakout cable. So you see on one hand, you have this 100G, which is used with QSFP28. So QSFP28 is a type of SFPs which is used for 100G connectivity. So it is used at the switch end. And on the other end, you have this 4 25G connections. So you can use normal SFPs, 25G SFPs, which are used at the CP server end. So 25G ports are used for control traffic and intercommunication of EPC nodes. LAC ports provide redundant connectivity connecting to different leaf nodes. So at the server side, you have the LAC ports that we have already discussed, LSCP.
One branch is breakup for entire cable to be replaced.
No, that if suppose this is faulty, only this port will go down, not this other three.
4 branches are there.
For one particular, it can so happen that one particular branch is down, but the other three will remain up. So server and leaf spine connectivity. So whatever connectivity we have of the leaf and spine, that is of 100G connectivity, and we are using AOC cables for that. And besides that, also the data plane servers have SmartDIC 100G support for fast path connectivity. There as well, we are using AOC cables. LAC ports provide redundant connectivity to two different leaf nodes.
But in diagram there, P routers also not connected.
P routers?
Not connected.
P routers actually, yeah, P routers belong to the BSNL side, so they have to handle that. Ours is up to the spine routers that will provide. So for the DP server and leaf and spine, we use 100G connectivity. And next we come to spine and provider edge router connectivity. So the connection here will depend on the capacity of the provider edge actually. If the provider edge supports 100G, then we can directly use QSFP28 and go for a 100G link. And just in case it supports 10G, then we can use a breakout cable. We can use a 40G SFP at our spine end, and we can use a breakout cable to break into 4 10G channels, and we can attach it to the provider edge router. But in our case in Chandigarh, we have the provider edge routers which are of 100G capacity. So we are using QSFP28 for it. So for the next part, underlay and overlay network, my colleague Himanshu will be taking over.
Hello. Hello. Yeah. Any doubt up till now? Right. L2, L3 handoff. See, from BSNL side, that VRF information we are taking, and that is taken into the sub interface at the spine level, and at the L2 level, leaf is working for that. Okay, IP handoff is taken at the spine level. L2, L3 handoff. Yeah, at sub interfaces with IP addresses configured, and that BGP session is being running between PE and the spine leaf. With eBGP is running. eBGP is running because they are in separate AS. They are spine and PE routers are present in different AS. They are using a private AS at spine level, and at BSNL side, the AS are different, I think. So eBGP is being used, and for no, we are not using VRF. Sir, we are running eBGP on sub interfaces. And we are running eBGP on sub interfaces basically.
And we are also using prefix list to import. We are also using prefix list. Okay.
We are using import and export prefix list at the spine level to import and export the rules.
We are writing the rules. No, both the sides.
From
our side as well as you have to write it at your end as well.
So moving on to this overlay and underlay and overlay network. This basically this underlay and overlay networks this basically categorizes the formation of a tunnel. For earlier we have that my colleague has told that we want to extend that L2 network over whole data center. So for that that tunnel is being formed between different leaves. To form an overlay network. That overlay network, for that overlay network, we are using the topology, that protocol, VXLAN protocol, for forming the overlay network. That forms a tunnel between different leaves and acts as an overlay network. And this overlay network is formed on the physical actual IP network that is being used to transfer traffic from one tunnel endpoint to another tunnel endpoint. So that traffic forwarding or routing of the traffic that is done from one tunnel endpoint to another, that forms the part of underlay network. So basically here we are segregating the L2 domain, extending the L2 domain over the underlay network to provide L2 extension over different area or different region. Where because see, we cannot use the L2 topology at all the end. Otherwise, our MAC address table will be too large, and we will have a problem of looping also. And we also want the L3 interfaces at different levels. That's why we cannot extend our L2 network directly. So that is why to extend our L2 network over L3 network, we have used VXLAN protocol. And underlay basically is the IP network that transforms the forwards the traffic from one tunnel endpoint to another tunnel endpoint. So here in this spine leaf architecture, you will know that leaf switches are acting as the tunnel endpoints here. And in data center, generally VXLAN, we can also use L2 VPN, L3 VPN, but VXLAN EVPN, VXLAN, this feature basically combines the usage of both L2 and L3 VPN with additional features as well. That is why in data center, generally this VXLAN protocol is generally preferred over another different tunneling mechanisms. So in this diagram, you can see that our spine router and that leaf router is acting as a VTAP. VTAP is the tunnel VXLAN tunnel terminating ending point, and another leaf. All the leaves present in this spine leaf architecture are acting as a VTAPs, and that VTAPs will be the tunnel endpoints for carrying the traffic from one VTAP to another VTAP. We are using the technology of EVPN multi-protocol BGP sessions, creating multi-protocol BGP sessions that will be using to import the EVPN routes from one VTAP to another VTAP. So that spine one, you are seeing that it is acting as a BGP route reflector portion. We are creating BGP sessions between spine and leaf for the for transferring the EVPN routes from one VTAP to another VTAP. So all the spine will have a BGP session with all the leaves, and since we do not want to make all the full mesh connectivity, that's why spine is acting as a route reflector, and all the leaves will be present here as a route reflector clients. So all the routes present from leaf will be gone through spine, and spine will distribute to all other leaves, all the EVPN route to other leaves. So you can see that one VXLAN tunnel is being formed with blue dot that is acting as the VTAP points, and that will be acting as an extension of the L2 domain over the another leaf, another L2 domain. So it is basically, and the forwarding of the actual forwarding of the packet from VTAP to spine or through data interconnect and then again back to spine and then leaf. That is the actual underlay network. That is the physical network which has been formed using the different routing protocols. That is BGP and IGP, OSPF, and all that. So the purpose is basically the transferring of L2 domain from one leaf to different leaf. So we cannot directly transfer L2 domain because otherwise the loop topology will be a big L2 topology. For that only VXLAN topology has been used. And it is basically a tunnel using underlying IP network. That communication from leaf to spine and then from spine back to leaf, that is basically done on IP basis. So that forms the underlying network for the tunnel point. So basically we are extending the usage of the L2 domain connections of the servers. If any server wants to connect with different servers which is located at different leaf, so that will do via this VXLAN tunnel only. Sir, basically suppose two servers are belonging to the same VLAN. So if whole you want to extend that, otherwise you have to at different leaf you have to use different VLAN because they are provided through L3 topology. So you cannot use the same VLAN and want communication between the servers. For that only we have used this VXLAN topology. Actually, ma'am, if leaf can be at the different data center part also, and this leaf can be a part of same data center also. All the leaves within data center and different data center are acting as a Vita point only, tunnel points only. Everything, if any packet from one server wants to go to leaf packet on different server that is connected to different leaf, but within same DC, that will also go through Vita only, Vita. Leaf basically terminates the L2 point, but above the leaf, all the information goes to L3 only. But leaf terminates at the L2. L2 termination is done at the leaf below. Below is the L2 level only. Below. What's that? Sir, this is basically not L2 tunneling. You can say L2 tunneling only, that all the L2 traffic is being tunneled over L3 network. Underlying network is the L3 network. Yes. And this you can see that any gas gateway with ESI lag, it is here that whatever servers with the same VLAN and same IP subnet present in one leaf, and if you want the same VLAN to be used at the different leaf, they will have the same gateway. So that is why that L3 gateway is an Anycast gateway for all the VLANs with the same IP subnet. So with the usage of Anycast gateway, any server with the nearest gateway, it will go to that leaf only. So that is why here Anycast gateway has been used in this VXLAN topology. Yes, sir. Basically, sir, you can see that any server with suppose with VLAN 50 and it has an IP address subnet support 10.0.2/24, and then L3 gate that VLAN gateway will be 10.0.0.1/24, and that subnet is also used at different leaf also. Any different leaf connecting different servers, that is also having the same VLAN, because you want both the servers to be in the same VLAN, but that is at the different connection with the leaf. So they both will have the same gateway. The L3 gateway that is configured on the leaf will be same 10.0.0.1/24. All the leaf with VLAN 50 will have the same gateway 10.0.0.1/24. Basically, and that all the VLAN will be part of same VNI. If any server with same VLAN wants to communicate different data center with the same VLAN, for that purpose only we want gateways to be same at all the leaf level with same VLAN.
Different locations.
Yeah, different location also with same VLAN, that will be the part of same VNI. Yeah, gateway IP will be same. Same gateway IP will be used. That is why here it is terminology is Anycast gateway, because server will reach to its nearest or nearest gateway. That is why Anycast gateway terminology. So it also basically it will minimize the R flooding and multicast flooding in this L2 domain extension. That is why Anycast gateway has been used. So these are the protocol that has been used for underlane overlay network protocols. OSPF is being used as an IGP protocol for communication between leaf and spine. And for forming the VTAP tunnel, we basically want the VTAP, actually for forming VTAP tunnel, some IP addresses are assigned to VTAP interfaces. So that interfaces IP must be known to the spine level. That is why IGP OSPF protocol is being used to transfer the VTAP IP address route as a host to spine level in order to form the EVGP EVP and BGP sessions, IBGP. Spine 1 is spine 2, leaf 1, leaf 2, and leaf 3, leaf 4. Here is the server. So to form the all the leaf will be acting as a meter points. Basically, VTEP has one IP address. Suppose you say IP address 1, and that IP address information is needed by S1 to form the EVPN BGP neighborship. For that only we are using OSPF protocol to transfer this information to spine. That is why that OSPF protocol is being used. And after that information is present on S1, spine 1, then it will use the EVPN BGP protocol to form the BGP neighborship. And ultimately, VTEP tunnel will be created using EVPN BGP neighborship points. All spine will be forming a IBGP neighborship the route reflector, which in the earlier topology you have seen. So in this way, it will all VTEP information will be exchanged with all the leaves which are the part of same DNI will have this VTEP information exchange from L1 to L4. And this any MAC address or that ARP information present on any server will be extended to all from L1 to L2, L3, L4, all leaves.
By mistake, by any chance, it will be VTEP one is
So the VTEP one IP address will be advertised to. Sir, this is not the gateway. This is the VTEP IP address, and VTEP forms a separate interface. Okay, and this basically this IP we want at spine 1 and spine 2 to form the EVPN BGP neighborship. So it will be present with leaf also, but it will not be present. Suppose it advertises also. No problem with that because we are not using this IP for any communication. Only for forming that BGP neighborship between spine and leaf. And that, sir, basically this IP we are configuring not on interface. This IP is being configured as a loopback. So BGP is protocol is also being used here, and that BFD protocol is used at BGP and OSPF protocol to form the faster convergence. And UFD protocol has been used to mark down the uplink and downlink failure. If any failure in the uplink happens, then it will mark down the downstream as a failed node in order to prevent all the backlog of any packet from the servers. So LACP is also used at all the levels to prevent the redundancy at the leaf and the spine level and at the node level also. So NTP is also used here to synchronize across the network for the time synchronization. Every leaf and spine node are used with the NTP server to synchronize with the time of the NTP server. TACAX, SNMP and syslog has been also used for the running of AAA and management services. And if you want any remote authorization or authentication for TACAX, that has been used. And syslog server has also been used here. So Anycast gateway, basically I have already told that these all 4 leaves will build their MAC table using that Anycast gateway information only. So that any server with its nearest gateway, it will go to that leaf only. So now that coming on to that this fabric connectivity with the BSNL side. So BSNL network has that core component part. It has different acting as a layer of different private AS autonomous system number, and our spine is at different AS number. So EVGP neighborship is formed between that the P router of the BSNL side and the spine side at our DC fabric, and import-export prefixes has been used to exchange the routes between BSNL P router and the spine router side. And one or more eBGP sessions as required has been formed over that 100G or bundled or multiple 10G interfaces in case you are using 40G interface of the spine to form 10G interfaces by using a breakout cable. Suppose our BSNL router does not support 100G interfaces. In that case, 10G interfaces with multiple bundling has been used. And to exchange the routes, we are using the network interconnect option A information. All the information at the BSNL PE side is coming at the VRF level. So we are using the sub interfaces to exchange the routes from that VRF to our different sub interfaces, and that sub interfaces will be part of different network only. So this
was 100% bundled 10 is required.
Sir, actually, if 100G support is provided at the BSNL PE router, then no need for the 10G ports. But in case if 100G is not supported at the PE router, then in that case only we will be using 10G ports.
Is it 80DC to 90DC also? Bundled 10 is required.
What, sir? Okay. Okay.
We are maintaining
With both you are maintaining. So, sir, whatever the link will be used, that will be. Okay, sir. So here also the bundle side at P side will be their bundle, then at spine level also will be 110G side bundle. Same connection will be used. Sir, actually 110 is like ports are different. You can bundle 100G port also, 10G ports also. Bundling is done at the port level. Speed can be anything, whether 100G, 40G, 25G, anything. So 10G is also a separate port, 100G is also a separate port. You can bundle both of them. Yeah, sir. Lag can be formed at both the ports, 100G and 10G side. But sir, but preferable will be that all the ports will be of same speed configuration. That will be better. To form that DC IP fabric, there are some inputs also required in order to actually know what will be the bandwidth usage, how many ports will be needed for server, so and how many servers and how many leaf and spine switches will be used. For that, these inputs will be required. So inputs are number of the computes. That is the number of the DP and non-DP servers. How many number of DP and non-DP servers are required? And the desired throughput of that data center, how much subscriber it will take care of, and the external port connectivity and the bandwidth requirement, and also the NTP, syslog, and TACAC servers for logging, and the IPv4 and v6 address pool of the private network, including the EPC node, and also that will be using for the inter-node networking elements also, and the loopback IP addresses for leaf and spine switches. VLAN pool range will be used also for EPC core elements, and the private AS number for spine node. These are the inputs required for forming DC fabric, and UE pool information to be served at the DC, and the NAT IP pool also for connecting UE to the internet. So NAT IP for public IP pool also required. So import and export prefix list also required at the spine level to exchange what needed to be imported and exported from that our spine to the BSNL PE router side, and that NNI details also, such as what interfaces, what VLAN and neighbor IPs are to be required. So these are all the information that will be required. By that only we will know how many leaf and spine switches will be used to form this DC IP fabric network. Coming on to this main and mini data center information, every main data center will have in every zone there will be one main data center and one GR data center for every zone. And that main data center will run basically all the control plane nodes only of the EPC code, and that mini data center will take care of the data plane nodes of that server. And for every zone, there will be one main data center and one GR data center and multiple mini data center. And that data center will be circle wise. And for interconnection between one data center to different data center, that data center interconnect or that VXLAN tunneling topology will be used for interconnection between different data centers. Sir, how many leaves will be used and spines? Sir, that information will be that earlier information that will be used depending on bandwidth and the subscriber and all that requirement. Using that thing, there is some script also, as some design team has some script regarding that information. With that script only, they will. Right, sir. Sir, that is only I am telling. Depending on the bandwidth requirement, only that information will be using that script only. That how many actually leave or that. At Chandigarh side, I think there is 6.
6 leaves and 2 spines.
6 leaves and 2 spines are being used.
2 spines at Chandigarh.
We have to make data center.
Sir, through IP MPLS only. No, sir, no point to point. Everything is through like our data center. That everything will go through IP MPLS cloud only. Sir, estimated bandwidth, I think 100G plus 100G something bandwidth may be required, because currently that I think 150 or 160G is being used at the Chandigarh side to take care between that spine and that IP MPLS transport cloud. So that much bandwidth, minimum that much bandwidth will be used at least. Sir, yes, sir, that is control plane only. But 100G only, right, sir? 100G only, sir. This is the typical data flow for any mini DC. For suppose this is the example for UE when it wants to use the internet. So UE will communicate to Inode B, and Inode B will communicate to all the spine of DC fabric using that BSNL IP MPLS network cloud. And since all the spine and leaf are using in non-blocking active ECMP based node, so whatever all the spine or depending on the traffic load and port present, all the spine may also get information of that. So spine will send to leaf, and leaf will send back to at the EPC core element for service chaining of any that internet packets. And again that from EPC core node it will come back to leaf, and then from leaf to spine, and then back to internet using that IP MPLS network cloud. This is the uplink direction of the traffic. Now for downlink also, traffic from internet will come to DC fabric through IP MPLS network cloud, and from that spine back again to leaf, and then back to this core element. Whatever core element will be needed to process that internet packet, like that netting and that firewall thing. And again then back to leaf, and then from leaf back to spine, and then back to Inode B using that IP MPLS network cloud. And from Inode B back to UE. So this is the typical data path flow for any internet packets. So for this is the service chaining service chaining of any packet which are being sent to internet. For that, what is done that whenever any packet comes from UE to that node B, and from node B it comes to SGW. SGWU or SGWP, after there that GTP encapsulation packet is taken out. From that, from PGW it is sent to DPI using that policy-based routing packets. Here PBR technology means routing of the packet based on the policy configured in the router. So policy you can configure on the source IP or any source protocol or any source or destination port. So in this leaf layer, PBR has been used for service chaining of the internet packets. For what is it? It has done that at any interface ingress level, some policies has been configured. Packet coming from PGW has been sent to DPI, and that DPI packet has again been routed to that firewall, and then from firewall to CGNet using policy-based routing only. And from CGNet again, it has gone to leaf layer where there is the default route for reaching the internet to spine, and then spine back to that IP MPLS network to the PDN network gateway. So this is basically the service chaining method. And depending on the further requirement of services, additional that service chaining nodes can be used, and that PBR rules can be formed to route the packet to that additional nodes in service chaining of the PBR. So this is the architecture for providing at the zonal level. There will be one primary redundant data center and another will be a geo-redundant data center, and their interconnectivity will be done through VXLAN tunnel. That is the L2 stage network only. And all the connectivity is via from one DC to different DCs via BSNL IP MPLS network connectivity. So this is the logical external connectivity for a particular zone. You can see that there is one PR main DC and there is one GR main DC, and there are multiple mini DCs. So in order to, and for each type of traffic, you can see different VRF traffic are being used here, like VRF OM, VRF media, VRF internet. So any traffic coming from that node be any different VRF that will be terminated at the PE router, and that will be using that sub interface often NNI that will be terminated at to the DC fabric. So any DC fabric from mini to main or main to mini or PR to GR, any communication is done through with that VXLAN tunnel only. So ultimately, all the packet will go from one mini DC. If it wants to communicate to another mini DC or main DC, so it has to go through IP MPLS network cloud only, and that for that only VXLAN tunnel will be used. Yes. Right, ma'am. Node B?
At DA level, it will be.
Yeah, I'm at DL level only.
The passing IP MPLS or DL.
This is the data center external connectivity requirements. See, internal connectivity we have already discussed, and for external connectivity, these are the requirements. As we already know that EPC core are realized in the form of VNF and CNF or a zonal cloud, and each zone has a multiple data center, that one PR, one GR, and multiple mini data center, all are connected via BSNL IP MPLS network, and all the external connection from DC to the BSNL P network are preferably done through 100G ports using option A and NI. And for multiple services such as media signaling, OMM and GNMP and all rest other features, FMCC, cloud, etc., are started as started and terminated at BSNL MPLS network, and that IP handoff has been done at the spine level in the 4G DC architecture over different VLAN interfaces. So that inter DC connectivity For inter-DC connectivity, we have an L2L3 handoff at the spine level with BSNL PE router. And for inter-DC logical connectivity, one more thing is that since we are using VXLAN topologies, there will be additional encapsulation will be done at the leaf level for VTEPs. So that will add extra overhead at the routers. So in order to take that care, we need to increase the MPU size at the peer level also. So jumbo MPU size is also being required at the BSNL transport network. At our side, we have increased the MPU size in order to take care of that tunnel thing, since additional encapsulation packets will be there. And BSNL IP MPLS network will be also configured if any QoS requirement is done or a requirement is being done, then at spine level, then BSNL IP MPLS network also need to take care of that side. So these are the external DC requirement for forming any data center. So any question regarding the DC fabric architecture in our 4G solution? What's that?
Fabric, main DC or very DC. What is sequence of procedures you will follow? Like first of all, installation. After power, after the what you will do.
That infrastructure wise, you are asking that how we will do that. First of all the requirements will be taken, that how the server and how that thing will be taken. After that, only that number of rooms and that number of spines will be known, and that using that only some config files are being generated, and rack also how many racks will be present.
So very much.
That hardware component already told that, yeah, it is from there. It is that leaf and spine are using, I think,
HP. Leaf and spine is HP.
And software is that of CDOT. And that hardware component is used for that is HP side.
Any idea of using SDN software?
Sir, I think
network?
SDN is right now not present.
Used like that. I heard that in this project.
So right now,
will
SDN
also
is
be
not
used.
present in this DC IP fabric architecture.
It can be.
Similarly,
but
this connectivity also we want a detailed, so you can collect if possible within this 4 days training. Because normally how it will be connected, all the RAN traffic aggregated, and everywhere we will have our own switches, routers, edge router, core router, all will be connected without the help of MPLS, that is a NIB network, our own MPLS network. But here, wherever we are telling that it will be connected through MPLS.
Sir,
So, what is the actual connection point there? Any switches, routers will be supplied to the field or that is here.
okay. Yes, sir, SCR also will be provided for that DEP.
How the connectivity system. That if you can call the Chandigarh and ask how the configuration is. Usually, what we do is we have to aggregate into one chip with the VLAN school level. Directly connected to a peer of
May not be how the control plane and the user plane reaches the respective PCs.
So actually that interconnection exactly how from IP that the MPLS cloud to that SCR router will be taken in the nearby that will basically
This SCR router is there. How this SCR router is connected to your leaf and spine?
from SCR router only so that 100 interfaces are being used.
That is point to point.
Point to point. That is basically the point to point connection. From SCR to P.
This SCR is supplied VA wise or
Yeah, sir. These are being used right now. 300 is the lowest right now. After that, yeah, after that only what we can information depending on that I think it is supposed to be submitted. How many links? How many? Yes.
Like what type of things you want?
That I cannot tell you that how many exact links will be used for the DTC connectivity with the backend server and DTC.
Instead of discussing about the generic or general, what we are going to get the field what features or routers you are going to supply. With that, if we are able to explain, you are explaining something, nothing will be there. It will be different. Get adopted out. Right. Yes.
Here is the broad picture only.
By this time, we should have known that clear-cut routing picture.
I mean, this will be the DC only, but from here, inner bit DC, how it can be that will be.
Few minutes, just one second.
So good evening, participants. Whether everyone has paper, the BSNL officials, sir? Everyone? So I got totally 45 numbers are there, names are there. Anybody is there? Everybody understood that all the BSNL officials were able to see this paper, we have entered your names and your servers and everything. So I'll just read out the name so that if you have left out, you can just write. So I got totally 45, out of which around 33 are masters. Anyway, let me just verify the names. 41 is no, I know it. So it's Ayyapan, C. Ramana, Ram Sudhir, Sudhir Benji, Mahesh, okay, and Husna Ahmad, okay, Angilal, Saranjeevi, Charan Singh, Samuel, Uday Kumar, Satyanarayana, Ashwini, A.R. Joshi, Uday Kumar?
This one.
That's okay, no issues. He is there now. Now, first, I just want to know that whether all the people are there or not getting this report or not. Uday Kumar is no this time. So, Satyanarayana, Ashwini, A.R. Joshi, Mukesh Kumar, Sampath Kumar Gupta, A. Kannan, D. Sridharan, S. Nirumara, J. Panu Vanan, C. Hemalata, M. Maya Krishnan, A. Manikandan, L. Sanjay Kumar, Naveen Bose, Mandara Meena, Lakshmi, Bhargavi, Ashwati, Avita, Kiran Kumar, Sharat Chandra, Pramod, Shirish Kumar, Dinesh, Madhavan, Manju, Until now, that was not good. That's Praveen. Okay, fine. That's Praveen. Jay Selman, Shivakumar, Balaji K, and Satish Kumar. Other everyone has name as a spell. Yaru left over here, but no days left over. Okay, so totally 45 participants are there from the center. As a total. Okay, so I can start 33 hostels. So do you want to confirm? As you only know, right? Yes, sir. So 33 are hostels. So what do you? Yes, sir, that's one. So I knew that you want the representation from hostels. You want to have any contact with the particular hostel instructions. Anyone?
क्लिक करके इसी पे क्लिक करके डाउनलोड्स यहाँ से भी हटा देगा डाउनलोड से निकल गया ये भी हटा दो पर उसमें फीचर नहीं था ना सर पिक्चर नहीं था
So now
पिक्चर भी
ये वाला presentation बता दो
So, but the hostel, the base section will get apart from the respective hostel, so that you can actually make the payment for the road aspects of this. For the base balance, you need but for the fee, only for the base loan, we are saying that you can actually make the payment of this time for the fee, only in after. For hostel, there is another package.
रीनेम कर दिए इसको सर रीनेम क्या तो कर देते
So tomorrow the morning class will be commenced by 10 o'clock. Please be here by around 5:55. Classes will be commenced by 10 o'clock. Thank you.
ये वाला है PPT they will share it.
A group may be created
If you send
So I think he is telling na what is this presentation. I think we need to share it now.
That's what I will create a group and will be doing.
You
today only.
Today you want it. Then you can take it from your email.
Okay.
You share the desktop, you can
share all the PPTs. Create
We are unable to see that. Today only you please share. Okay.
It is there. You can get it from your email. Then I will share the photo. You create a group.
Share today, no issue.
It is there. You have to so it is there in the desktop. You can get it in your email. Oh, that's what. They are asking. So if it is already is there, so that we can build it. So they are asking that is it possible in the prior day, so that they can have a
already all the presentation, even tomorrow's presentation is already here.
Okay.
You better create it and send it. Before presentation, if it will go na, it will be easy for them to see.
Yes, yes. So we will and we will check all the PPTs advance also. So not after the completion, all the we share in the group so that you can have a week before coming for the classes also. So these
Excuse me. Tomorrow we need a connectivity with the Chandigarh. Internet through internet and the global protect is there required. Na? Then we need to connect our laptop with the global protect.
864.
In our laptop we have. Then you need internet. We need it.
Mail is WhatsApp. You can forward others also. You can forward the others also.
You can send it to us. System system is
Phase is not,
It's only core. Only core for 2 days. Tejas team will come on day after tomorrow.
it's uploading, sir.
994 0000 860. Method లో రావడం కొంచెం టైం పడుతుంది. యాడ్ కాంటాక్ట్ పెట్టండి.
డైరెక్ట్ గా కాంటాక్ట్ షేర్ చేసిన కూడా డైరెక్ట్ గా పంపించవచ్చు.
ఏపీ నుంచి వచ్చేసారు.
Other family owners.
You are.
Sir.
Still it will take time.
Meeting answer not participated in the meeting.
This is the WTP, FTP. This is for FTP or airport.
Sir, this is the system. Whether you have received or the issue system over. No, some issue is there. Our R&D experts are suggesting to go for JSON expansion to the No. Middle of the November it won't issue. ఇప్పుడు షార్ట్గా ఇష్యూ అలా అవుతుంది. Data.
Stop screen sharing also.